So today's lecture is a continuation of the last lecture. But before considering the circuit diagram, we are going to look at the definition of voltage. So what is voltage? Voltage V is defined as the work done or energy transferred per coulomb of charge. This means that voltage represents how much work is done or how much energy is transferred per coulomb of charge. So when 1 coulomb of charge flows through the circuit, how much energy is transferred? So from this equation, we can deduce the base unit. So from this equation, the base unit of voltage is joule per coulomb, as the SI unit of energy is joules and the SI unit of charge is coulomb. So the unit of voltage is joule per coulomb, which is equivalent to volt. So what is 1 volt? So 1 volt means that the amount of work done on 1 coulomb of charge is 1 joules. Similarly, when the voltage is 2 volt, this means that for 1 coulomb of charge, the amount of work done will be 2 joules. Now, let us consider this circuit diagram. So in this circuit diagram, we can see that there is a 12 volt battery and there are 2 resistors connected in series. Now, considering this circuit diagram, the value of the voltage of the battery is 12 volt and the voltage drop across the first resistor is 8 volt and the voltage drop across the second resistor is 4 volt. Now, when 1 coulomb of charge is passing through the circuit, we can say that as 1 coulomb of charge is passing, therefore this 12 volt will mean that it is giving this 1 coulomb of charge an energy of 12 joules. Similarly, when this 1 coulomb of charge has gained 12 joules of energy, when it passes through the circuit, it will lose some of the energy until it loses all the energy. So for example, when this 1 coulomb of charge passes through the first resistor, the energy lost is 8 joules. So we represent this loss of energy by negative 8 joules. And after passing through the second resistor, the 1 coulomb of charge loses the remaining 4 joules of energy. So here the charge 1 coulomb has already lost the 12 joules of energy. So when the charge flows from a high potential to low potential, the voltage drops or the charge loses energy. But when the same charge moves from the lower potential to higher potential, for this battery it's moving from minus to plus, this 1 coulomb of charge will gain 12 joules of energy. So in this circuit, we can say that the voltage rise means the voltage supplied or the energy supplied by the power source or battery will be equal to the energy lost or the voltage drops. For example, the energy losses here is 8 and 4. When we add these 2 losses, we get 12 joules and the energy supplied was also 12 joules. Similarly, if we consider voltage, voltage rise is equal to voltage drops. For example, the voltage rise here is 12 volt and when we add the voltage drop, it is also 12 volt. Now, moving on to this diagram, we can see that this circuit element has 2 points, point A and point B. Now, the point A is positive and the point B is negative. So what does this mean? This means that the point A is at a higher potential than point B. So when we consider these 2 points A and B, we will see that there is a potential difference. So the potential difference between these 2 points A and B is denoted by VAB. That is the potential difference across 2 points A and B. So this VAB is equal to VA minus VB. Now, why it's VA minus VB? Because VA is greater than VB. Now, if we consider this one, we can see that the potential of point B is higher and the potential of point A is lower. So in this case, when we connect a voltmeter across these 2 points, and if we connect the positive terminal here and the negative terminal of the voltmeter there, we will see that the value of the voltage is negative. Why it's negative? Because our assumption was wrong. We assumed B to be higher potential than point A, but in reality A is at a higher potential than point B. That means this two condition is similar or equivalent. So we can tell that VAB is equivalent to minus VBA. So now what is the difference between potential difference and EMF? Obviously, EMF and potential difference is not the same. Now, what's the difference? Potential difference is the difference in potential between any 2 points. For example, here, the potential difference is between point A and point B. So, when any 2 points are at a different potential, then there is a potential difference. But what is EMF? EMF is actually the voltage that is supplied by the power supply, and the voltage supplied by the power supply represents the amount of energy gained by 1 coulomb of charge. So the power supply supplies some energy to the charge. So the voltage of the power supply actually represents the amount of energy that is transferred to 1 coulomb of charge, or in other words, the amount of energy gained by that 1 coulomb of charge. For example, here the amount of energy gained by this 1 coulomb of charge is 12 joules. And the potential difference, as I said previously earlier, it is actually the difference in voltage between the 2 points. So it can be of any component, like between these two, among these two resistors. If I consider the first resistor, there is a potential drop of 8 volt, and here there is a potential drop of 4 volt. So between these 2 points, here and here, there is a potential drop. This point A and this point B, these 2 points are not at the same potential. There is a potential difference. This point A is at a higher potential than this point B. Why? Because when the charge moves from A to B, the charge loses its energy. So the potential drops.